In the last video, we learned how recommendation system work, how platform understand what you like and then suggest content accordingly. But here is the real question. How do machine actually see you? Not just clicks, not just preferences, but your face, actions and surrounding in real time. From unlocking your phone to detecting objects in self-driving cars to identifying defects in manufacturing. This is where computer vision comes in. It's the technology that allows machines to interpret and understand visual data, just like human eyes but powered by AI. And the reality is, they don't just recommend, they see you every time. So in this video, we are going to break down how computer vision actually works, step by step, in the simplest way possible. Let's get into it. So, how does computer vision actually work? It all starts with capturing visual data. Cameras and sensors collect images or videos from the real world. Next, we prepare and label the data, cleaning it, organizing it, and tagging important features so the system can learn properly. Then comes the core step, training AI model, where algorithms learn patterns, shapes, objects, and behaviors from that data. Once trained, the system can detect and analyze, identifying objects, tracking movement, and spotting anomalies in real time. Behind the scene, models are continuously refined, improving accuracy through evaluation and more training. And finally, we trigger business actions, alerts, dashboards, automations, or real-time decision based on what the system sees. So, the pipeline is simple: capture, prepare, train, analyze, and act. That's how machine learning turns visuals into intelligence. To truly understand computer vision, you need to understand its foundation. These are the five pillars that power everything behind the scene. First, data is the key. Without high quality data, even the best model will fail. More data is equal to better learning. Second, learning from data. Models don't think, they learn patterns from examples. The more diverse the data, the smarter the system. Third, getting faster and smarter. With better algorithm and hardware, systems are becoming faster, more accurate, and more efficient. Fourth, measuring success. It's not just about predictions, it's about how accurate, reliable, and scalable those predictions are. And finally, from theory to application, what starts as research becomes real world system. Healthcare, security, automation, and beyond. So remember, computer vision isn't just about seeing, it's about data, learning, performance, evaluation, and real world impact. That's what makes it powerful. Now, that we understand how computer vision works, let's look at where it's actually used in real world. Computer vision isn't just a theory, it's already powering multiple industries around us and from a long time, starting with intruder detection. AI systems monitor environment and instantly detect unauthorized access using cameras. Next, assembly verification. In manufacturing, vision systems ensure every part is correctly placed with zero manual inspection. Then comes screen readers, helping visually impaired users to converting images and text into audio. We also have OCR, optical character recognition, which extracts text from images, documents, and even handwritten notes. In industries, metrology plays a key role, measuring objects with extreme precision using vision systems. Another critical use is defect detection. AI identifies even the smallest flaws in products, improving quality and reducing waste. And finally, computer vision with robotics, using its automation like bin picking, where robots identify and pick objects intelligently. So as you can see, computer vision is not just seeing, it's analyzing, deciding, and acting in real time. And this is just the beginning. Now, let's talk about the real business impact of computer vision in manufacturing. First, fewer errors. Automated visual inspection reduces human mistakes and ensures consistent quality. Second is increased productivity. Machines work faster, continuously, and without fatigue, boosting overall output. Third, reducing cost, less rework, fewer defects, and optimized processes directly lower operational expenses. Fourth, improved safety. Hazards detection and monitoring system help prevent accident on the shop floor. And finally, better product quality. Precision inspection ensures every product meets high standards before reaching customers. So, the value is clear. Computer vision is not just a technology upgrade, it is a performance multiplier across the entire manufacturing pipeline. Higher efficiency, lower cost, better outcomes. So, if you are actually wondering where do you actually start in computer vision, here is the actual roadmap you should follow. Step 1, Basic Mathematics and Computer Science. You need the foundation in linear algebra, probability, and basic algorithms. This is not negotiable because mathematics is very important in AI. Second step is programming skills. Focus on Python, learn libraries like NumPy, OpenCV, and basic data handling. Step 3, Machine Learning Framework, Tasks and Methods. Understand how machine learning works, classification, regression, and especially neural networks. Use frameworks like TensorFlow or PyTorch. Step 4, Data. Everything revolves around data. Learn how to collect, clean, and pre-process images properly. Step 5, Models. This is where you build CNN, convolutional neural networks, object detection models, segmentation models. Train them, test them, improve them. Step 6, Evaluation. Measure performance using matrices like accuracy, precision, recall. If you can't measure it, you can't improve it. And finally, step 7, Go live. Deploy your model into real-world system, work with real production data, and continuously improve. The roadmap is simple. Learn, code, understand ML, work with data, build models, evaluate, and then deploy. Follow these and you move from beginner to real world practitioner. Before you jump into building model, you need to understand the fundamentals of computer vision. This is where everything starts. First, we have to understand what is the edge detection. This is the most basic level of vision. The system learns to identify boundaries, where one object ends and another begins. Like, imagine you have a cat and you are watching it. How you will identify it is a cat? You will draw an imaginary outline around it in your brain, and the brain will process it, and then you will come to know it is a cat. The shape is the key. Then, feature extraction. Edges alone are not enough. The model starts identifying patterns, shapes, textures, and important visual signals. As from the earlier example of cat, when you are watching at a cat, you can see the hairs, the colors, the texture of a cat, the shape, all these combined, then you come to know it's a cat. You understand it's a cat. In the same way, feature extraction works. Color transformation. Images are not just pixels, they are data. We convert color spaces to highlights, useful information, and reduce noise. So, only the important parts or important colors are taken into consideration, and noise, like which are not useful, is ignored. And finally, object detection. This is where everything comes together. The system recognizes and locates real-world objects inside an image using all these systems like color transformation, feature extraction, and edge detection combinedly. So understand this clearly. Machines don't see like humans. They break images into edges, features, patterns, and objects. If you skip this foundation, you won't truly understand how models work. Master the basics first because every advanced AI system is built on this simple step. So now in the next part of the video called You Use Machine Learning Daily but You Don't Even Know It, we will learn more about generative AI. What are the types of generative AI, how it works, where it is used, and all the other things about it. So subscribe to my channel, like this video, and learn tech simple. Comment your feedback below so I can improve in the next video. Thank you for watching till the end.